So I'll teach you the derivation of rectification efficiency. Tell me, according to you, what is efficiency? Efficiency is what? No, that is output divided by input, and it is in percentage, so multiplied by 100. Like I'll say you that I gave you 5 questions in your homework, okay? And out of that you have done only 4 questions. So how much is your efficiency in this case? 80%. 5 questions I gave you, that is your input, okay? And 4 questions you have done, that is your output. So you have done output divided by input multiplied by 100. So that is 80%, okay? Similarly, we'll do it in the case of rectifier, that output power is equal to input power, right? Tell me, what is the output power in this case? Hello? Yeah, tell me. No, no, I'm asking in terms of rectifier. Like I'm asking in terms of rectifier. Yeah. So that is the output power. Output power is in the form of AC or DC, because rectifier is converting, output is in the form of DC. Okay, PDC, because we are converting, rectifier is converting AC to DC, right? So that is PDC. Similarly, input power is denoted by PAC. So we can say that efficiency is PDC divided by PAC multiplied by 100, right? Now we should know the formula for PDC. According to power, power is equal to I square R, right? If DC is there, so IDC will use and RL will use, correct? So this would be formula for PDC. Now next, PAC formula. PAC formula is again I square R. So that would be I square RMS. RMS means because we are giving the AC supply. And as you know, in the AC supply for calculation we'll use IRMS, right? So in the input we are using two resistance. One is the diode resistance and another one is the load resistance, correct? Because as you know that rectifier, this is kind of rectifier, right? So this is RF plus RL, right? So in input we'll give supply to the both, right? Now we are having the value of PDC and PIAC. Can we put it down? So efficiency would be how much? PDC efficiency is how much? PDC divided by PAC, right? PDC is how much? I square DC into RL divided by PAC is how much? I square RMS, that is RF plus RL, right? Any doubt up to here? And we are doing for half wave rectifier, okay? And as you know, IDC formula in half wave rectifier is how much? That is Imax by pi, correct? And IRMS formula in case of half wave rectifier, that is Imax by 2. So can we put down the values here of IDC and IRMS? That would be Imax by pi whole square multiplied by RL divided by Imax by 2 whole square into RF plus RL, right? So if we'll solve it, Imax would be cancelled out. What is left? 4 is here and pi square is here. So if we'll solve it further, we'll get efficiency is equal to 4 by pi square into RL by RF plus RL is as it is. Correct? RL, RF plus RL is as it is. So if we'll solve 4 by pi square, okay, then what can we can get? RL we can take common from this denominator. We'll get 0.406 into RL. Again, I'm taking common RL common from the denominator. What would be left? 1 plus RF by RL. Correct? So this RL would be cancelled out. The left term is 0.406 divided by 1 plus RF by RL. Okay. Now, if we'll neglect the RF, why? Because as you know, diode resistance is very less than the load resistance. So RF is neglected. So we can say that RF is 0, 1 plus 0 is 1. So the efficiency would be how much? 0.406 multiplied by 100, that is 40.6%. Okay. Remember I told you the formula also for the rectification efficiency, that is 40.6%. Okay. Now we have derived it that we got the efficiency as 40.6%. That is for the half wave rectifier. Okay, clear?